Hello, grade 11, Mr. G here, and this video we are going to be talking about Newton's law of universal gravitation. Okay, so let's start by stating the law. Okay, this law states every point mass attracts every other point mass by a force which is directly proportional to the product of the masses. The force of attraction between the object is directly proportional to the product of the masses. Product of the masses of the 2 point masses of the two objects. That is the first important, very important thing here. Okay? Is the force is directly proportional to the product of the masses of the object. The second important thing is that is inversely proportional to the square of the distance between those two objects. So these are the two important parts of this law. First one, the force, which is the force of attraction. So this is an attractive force. That is important. It's always attractive force between any two objects in the universe is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Be careful with the word square, okay? Otherwise, it's going to be wrong. So, the mathematical expression for this law is the following. The mathematical expression for this law is this one here, in which M represent the mass of the object. Mass of the object, and the mass must be in kilograms. Always must be converted to kilograms. R, which can also be written as D, it does not really matter, is the distance between the center of the object. Is the distance between the center of the object and must always be expressed in meters. So be careful with this data. And G, capital G, stands for a gravitational constant. This is the constant, and that constant is equal to 6.67 times 10 to the minus 11 Newton meter square kilograms per kilogram square. Okay, but this is not that important, the unit. However, you must know the unit. This is G and is a constant. All right. So if we write the relationship, not the formula, we have that the force of attraction is directly proportional to the product of the masses of the object and inversely proportional to the square of the distance between the object. From here, we can divide this into two parts separated. The force, which is always attractive force, is directly proportional to the product of the masses of the object. So if any of the object, or if the mass of any of the objects then is double, then the product will give you a double force. Okay, and from here we know that the force of attraction is inversely proportional to the square of the distance between them. So if the distance is double, then the force will decrease 4 times because it's from there is to the square. So this is very important. This is the relationship that you must learn. This is in fact the law, but in a symbol. This is the same law, but using symbols now. From here, we can have two graphs. One for the relationship between force and mass, of the product of the mass. This one is one graph of force against the product of the mass. This is the product of the mass, and it's going to be in straight line because it is directly proportional. And we can have another graph of force versus distance square. Remember, it's distance square. Let's keep using the R not to get confusion. However, it's the same. R square, and then here the graph will be a curve. You can see. Sorry, that curve is not right. So it's a curve in such a way. As the distance decreases, the force increases, and so on. So this is very important in terms of the graph. Let's see different 2 or 3 different scenarios so you understand this relationship. Okay. So let's see. We have an object M. Object M1 and an object M2. All right, those objects are separated from the center to the center a distance r. Okay, so for this scenario, let's say the force is going to be equal to the acceleration due to gravity. That I beg your pardon, the constant of gravitational constant multiplied by m1 multiplied by m2 divided by the distance square. All right, so now let's have the same scenario, exactly the same, but one of the masses is going to be double. So this is 2m1. All right, it's double 2m1, and the other one is going to be exactly the same as before. Okay, m2, we keep it like that. The distance is the same, still r. So now what we have here, we have that the force is going to be equal to constant of gravitation 2m1 multiplied by m2 divided by the distance square. Distance didn't change. If you take this one out, you have that F will be equal to 2 multiplied by g m1 m2 divided by the distance square. This one here is the first force. So that means that the force, the new force now, is equal to 2 times the force 1. So the force increases 2 times. I hope it's clear. All right. Let's have another scenario in which we have in the same object as the beginning, m1, m2, but the distance is going to be now double. So this distance here is not r1, it's going to be 2r1. How do we find out what is the what happened to the force, how the force changes? So the force is equal to mg multiplied by m1 m2 divided by distance square. Is that correct? But distance square now is 2, it's double. So we are not going to write distance square, we write 2 r everything square. And if we solve this one, we have g mesh 1 mesh 2 divided by 4r square. If we take this one out of the fraction, we have that the force is equal to 1/4. I have 1/4 of g m1 m2 divided by distance square, and the same as before, this is the 4. So the 4 is now 4 times smaller. This is important. This is all about this video, is just to understand the law which stays there, is to understand the relationship. I hope it helped. Next time we are going to go to some questions about this one, some calculation per half, and we still have to speak about the acceleration due to gravity. Thank you very much for watching, and good luck, and I'll see you next time.